Good morning from Los Angeles, California. This is week number 6, and this is Interactive Advanced Concept Presentation 6, or the nuclear bomb. So today, obviously, we're not going to make a nuclear bomb because that, first of all, is very difficult to find out the information for it, but we'll go into that. And also, that would not be very good. So today, we're going to talk about the type of nuclear chemistry that is needed for a nuclear bomb to work, what components are necessary to achieve the chain reaction required for nuclear fission, and the components necessary for this to work. So first, let's talk about the history of the atomic bomb. An atomic bomb is a nuclear weapon that has also been referred to over time as the atom bomb, the A-bomb, or nuclear warhead. It's an explosive device that derives its destructive forces from nuclear reactions, either fission, like a fission bomb, or from a combination of fission and fusion reactions, like a thermonuclear bomb. When an atom of a radioactive material splits into lighter atoms, there's a sudden, powerful release of energy. The discovery of the nuclear fission opened up the possibility for nuclear technologies, including nuclear weapons that we're talking about today. So the nuclear bomb contained about 60 kilograms of uranium-235, of which only about 600 grams underwent fission, enough to generate an explosion equal to more than 13 kilotons of TNT, which is a whole lot. The bomb's designers divided the amount needed into two pieces at the tip. They placed about 40% of the necessary uranium, and they loaded the remaining 60% at the other end of a conventional explosion device, and the projectile into the target, initiating the nuclear explosion. While most bomb components are classified, so they can't be created in the wrong hands, the most difficult part is obviously preparing the uranium, and that is also very difficult to obtain. The government also looks at whoever's trying to get uranium to keep track of possible nuclear bomb-making materials. So I'll talk about the history of the United States, too. So the Manhattan Project was a codename for an American-led effort to develop a functional atomic bomb during World War II. The Manhattan Project was started in response to fears that German scientists had been working on a weapon using nuclear technology since the 1930s. On December 28, 1942, President Franklin D. Roosevelt authorized the formation of the Manhattan Project to bring together various scientists and military officials working on nuclear research. Much of the work on the Manhattan Project was performed in Los Alamos, New Mexico, under the direction of physicist J. Robert Oppenheimer, and he is considered the father of the atomic bomb. On July 16, 1945, in a remote desert location near Alamogordo, New Mexico, the first atomic bomb was successfully detonated, and this was called the Trinity test. It created an enormous mushroom cloud, some 40,000 feet high, and that was considered the start of the atomic age. There's actually a museum at that location, and you can go see it, and you can see the crater that's over there. I haven't seen it, but I'd like to one day. So scientists at the Los Alamos area had developed two distinct types of atomic bombs by 1945. The first was a uranium-based design called, and they named it Little Boy, and the second was a plutonium-based weapon called the Fat Man. The atomic bomb was used twice in war, and both times used by the United States against Japan at the end of World War II, in Hiroshima and Nagasaki. On August 6, 1945, the United States dropped its first atomic bomb, which was from a B-29 bomber, and it was dropped over the city of Hiroshima, Japan, and that was Little Boy. And it exploded with 13 kilotons of force, and it leveled 5 square miles of the city, killing 80,000 people instantly. Later, thousands more died from associated radiation exposure. When the Japanese did not immediately surrender, the United States dropped a second atomic bomb there 3 days later on the city of Nagasaki. That bomb was the Fat Man, and it killed an estimated 40,000 people on impact. There's still people in Japan that suffer from the effects of radiation today, and it's still being monitored in those areas because you can still detect radiation. So that's important to know of why people are so afraid of nuclear weapons today. It's hard to imagine as an outsider the magnitude of devastation following the dropping of an atomic bomb, but I'm fortunate to have been able to travel to Hiroshima to see the aftermath that still stands today. It's pretty amazing, and I encourage anybody who's in Japan to see it firsthand so they can better understand all of this. So following World War II, around 1947, the Cold War began, which ended around 1991. And during this time, political tensions between the Soviet Union and the United States, along with each of their respective allies, though there were never actually any physical fighting between these two countries, they continually antagonized each other because of through political maneuvering, military stuff, espionage, propaganda, arms buildup, economic aid, proxy wars between other nations. It was a really bad time, and it spurred a lot of protests here in the United States. So the United States and the Soviet Union took the lead in negotiating an international agreement to halt the further spread of nuclear weapons in 1968, which I think was very much needed and important. The treaty was called the Non-Proliferation of Nuclear Weapons, also called NPT, and it went into effect in 1970, and it separated the world's countries into two groups, nuclear weapon states and non-nuclear weapon states. The nuclear weapon states included the 5 countries that were known to possess nuclear weapons at the time: the United States, the USSR, which is now Russia, Great Britain, France, and China. And nuclear weapons are still around today, but they're closely regulated, or we hope they're closely regulated. Obviously, there's a lot of tension with North Korea regarding that, but there's a lot of unknown too. So that's a bit about nuclear weapons, and I'll see you next week for week number 7. Bye for now.